Hello everyone, welcome back. Today I'm going to be tackling a few bits and bobs, so it's going to be all different sorts of stuff. Squeak, look up there. As you can see, I've got a load of plugins and what the scope and whatnot, but up there and sort of over the years, all the sort of things that I don't know quite what to do with and whatnot has just got thrown up there, and it was just ridiculous. I couldn't really. It was just a big pile of stuff. So, to try and make some space and everything, I pulled everything out yesterday, or most of it out, and I'm going to try and fix stuff today. Well, I'm just having a look, I'm just messing about, just sort of taking a break. All week I've been working on a valve amplifier and computers and everything, so I'm just having a bit of fun. So if you're into electronics, you find that you get talking to neighbours and people and they say, oh, I've got such and such, you can have this, or oh, I've got this, blah blah blah, and you end up with stuff. Bloke I know down the road, Dave, says, Andy, I've got this guitar amplifier, it doesn't work. Well, I don't want a fucking valve amplifier, pardon my French. I mean, especially a solid state one. Valve one, yeah. But anyway, so I don't know, I never say no. So here we have a very cheap arse guitar amplifier. Here's the speaker that came out of it. Cheap as chips. What is it? Guitar amplifier. It ain't even got a name. Let's see if it has got a name on here. Nah. All that on the back. It's a Sound Lab guitar amplifier. Ooh. Anywho, so like the amp before, I've given it a visual inspection. Can't see anything that's blown, although straight away, just by looking at it, I can sort of figure out potential problems. But first, let's start with a power supply. You always start with the power supply. Here we've got a couple of fuses. We've got our mains coming in. One half goes to a switch, so it's only switched on the live, which is a bit iffy. I always use double pole single throw switches, so the live and the neutral is switched. That goes in there, and that basically goes straight into our transformer, so there is no main fuse protecting the switch and transformer as such. And then we've got a secondaries coming out. I would think that is what, probably 12 volts, something like that. We've got a couple of fuses here. Both of those are okay. I checked them, although I haven't checked if they're the right value, which is always a good thing to do. Then, as you can see, we have, if I zoom you in a bit, we've got 4 rectifier diodes. They're probably something like a 1N7, no, hold on, 1N4007, something like that probably. Got 4. And then we've got another 2 there. Don't know what they're doing. I checked those. Last night, Saturday night, I just drew out a rough schematic of the bridge rectifier and the diodes and the caps and everything of the power supply of this cheap arse amp. So I know what is going where, so I can make sense of the bugger, right? So usually you have your fuse on the AC, then it goes into your diodes. What's the point in having it after the fucking diodes? I mean, if one of those goes, so you'd have your fuse there. That's me, fuck knows. Anyway, C4, that's a positive rail, C5 negative rail. So next we need the oscilloscope. The oscilloscope helps if you don't short things out. Right, see, we've got like a big sine wave. On the other end, it's rectified. Alright, this is not making sense now. Well, this is about a day later, and I spent all yesterday trying to figure out what the frick was up with this thing. A few times I nearly just chucked it in the bin because I don't particularly want it, but when I can't fix a thing, that's a challenge, and I'm not having it. So, for some reason I couldn't get the positive rail. I don't even know what it is. It's plus something, 12, 16, I don't know. think the caps are rated at caps are rated at 16 volts, so plus 15, minus 15, 12, something like that. Anyway, I could get the negative rail, not the positive. Scope the diodes, because what I noticed was when I was powering up, got AC here, which comes in off the transformer. I'll tell you about the transformer in a minute. Nice wave, and then scoping each individual diode in the bridge rectifier ensemble. I noticed like you get like a bump, 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 but then they got smaller after a while. I'm thinking something's pulling it down. Well, if you look here, zoom you in. Yes, this here is our positive rail. See? Over there. And it's attached to a 78L05 regulator, little regulator, which regulates the voltage for this delay chip. And it goes up here, and there's not really anything else. Oh, and the LM18 whatever it is power amplifier chip. Disconnected that, pulled the the 78L05, still doing it. Right, it's got to be the capacitor then. Check the capacitor. Fine. Put in other various capacitors, still having it. And then at some point I noticed that the AC waves coming off it were different. They were a lot smaller, and it just looked like background AC hum. So the transformer's fucked. Whether the transformer was a bit fucked before, and I do not know. So with that, I've spent enough time on this damn thing. I don't know what's up with it. Like I said, there's only a couple of things attached to the positive rail, and that's this 78L05 regulator and the LM1875T amplifier chip. That test fine, there's no shorts across it, no idea. So I don't want to spend any more time on it. I think what happened is, being a cheap Chinese piece of junk, most of the mains transformers are rated for 220 or 230 mains voltage. Our mains voltage round here is 247, near 250 volts RMS. Don't think that did that much favours. The transformer buggered up. I don't know. Can't be arsed with it anymore. Fuck it off. Right, let's go and have a look at the next thing. So one of the projects, unfinished projects, was this amplifier that I built, looking back at various records in 2016, 9 years ago, and I knew even less than what I know now. So I think it was the first transistor amplifier that I built, and we'll look at it in a minute. Let's just see what it's based on. It's based on an amplifier design in Elektor summer circuits, July August 1984. I'll zoom you in. Pretty simple, what do you call it, amplifier schematic. So we've got the usual differential pair, long tail pair here. That's being fed from a constant current source up here, which I modified because those two diodes there are hard to get. I think they're 1.5 volt across, and they're like a double diode in one package. Anyway, I used LEDs, as you'll see in a minute. So you've got two current sources, sinks, whatever. One there feeding differential pair, another one here feeding these two transistors here. This forms our class AB amplifier there. This is our VBE multiplier, which sets the current going into the two output transistors, which are BDV76C, BDV66C, Darlington power transistor. So as you can see, it's one of my do-it-yourself circuit boards. and I hadn't really finessed the technique there. As you can see, the holes where the components go through, I must have drilled them just with the engraving bit, you know, no little drill or anything. Potentially to just sort of fucking hanging about in space. As you can see, these are our, I would presume, LEDs for the constant current sync sources. That must be our driving transistor. And at the back there are our power transistors, Darlingtons. I've gone really overboard on how to clamp them down. I did the same on there as well. Yeah, I mean, it doesn't look too bad. We'll have a look on the reverse side in a minute. This is a heatsink off an old Pioneer amplifier I found in the back of a pub with a tree growing through it. So the amplifier was totally buggered, but they had these really nice little heat sinks on there. We've got a toroid transformer and two, and they look like ex-military Sprague Lambda. Yeah, must be 7,800 microfarads, 60 volts DC, 90 volts surge. That's it all connected up properly as far as I know. However, this is why we use a lamp limiter. That is not looking good. So what I did earlier on, I checked all the underneath, checked most of the connections, made sure that I got things mostly right. One thing I did screw up on, was it 9 years ago? I think I mentioned this. They aren't 1.5 ohm, they are 15 ohm. So instead of having 0.75 of an ohm emitter resistance, we had 7.5 ohms. Looked all through me resistor stash. Have I got one? No. So I've just used 1 ohms. Just used 1 ohm, which is a little bit bigger, but it's okay. Best be on the safe side. Oh blimey, I'll cut that rain. That looks setting for the day, that does. Where are we? Oh no. 12th of November. Anyway, back to the amplifier. I do like it. I do like the rain though. I'm going to stop and watch it for a bit. Got me cup of coffee, morning cup of coffee. With only 11 volts on the rails, so 20 volts across the whole thing, I measured 0.36 volts across these 1 ohm resistors. That equates to a current across those emitter resistors of 2.7 amps. Which is wrong. And across this 680 ohm resistor there, which should tell me what the bases of the two output devices are set at, I measured 940 microamps, so that's not the problem. There's something wrong there. Right, it was a screw up on my part. That's why when you've made changes, you always bung it on a lamp limiter. So our pin out of our BDV66B is BCE, base base collector emitter. This resistor should go from its emitter to there. At the moment it's going from the negative, yeah it is. It's going from the collector to the output. The other one is right, this one is wrong. Right, that's that resistor, put where it should be. Switch on. Hey! Ding dong. Point you at the meter over there. 40 volts. Lovely. Lovely jubbly. Positive rail. Hold on, I'll not do it on the board, I'll do it here where it's easier. 40. Smashing. Fantastic. Knicker elastic. Right, we seem to be okay. We've got 40 volt rails. I'm just going to check the all the voltages, DC conditions. I have the scope probe on there because I'll try and point this resistor here with that capacitor there forms part of the Zobel network, and I noticed yesterday it had got a bit warm, meaning perhaps in the past this amplifier was oscillating. It isn't oscillating, so I'm just going to take that off. I have just tried to see if I got an output and I haven't, so we're still not out of the woods. So what I'm going to do now, I've put some tape over me probes because it's so easy to slip in there. I mean, luckily, like, I've spaced like the leads out okay and everything, but yeah, just one slip, bang. So let me take them off camera and I'll see you in a minute. Just took some DC conditions readings. I'm not quite sure what they mean yet. I haven't had a chance to analyse them. However, there we go. We've got an output. Hooray! Calucaleo Frab yesterday, he chortled as he walked. There we go. Got a nice sine wave output, 4.7 volts, 4.8 volts RMS, 1 kilohertz. There's a little bit of jiggering about. I don't know if you can see that on the screen there. I think me pot that I'm using and me connections in are a bit iffy, and like I say, the layout's not brilliant. Let's have a look at the THD, 0.3%. so yeah, let's have a look at 100 kilohertz. If my left hand, ooh, well that's not good, is it? Got a really bad low frequency response, frequency 20 kilohertz. Right, well that is atrocious. There's something not right there. Let me just see what I've got going in there. I think it's my volume pot. Okay, yeah, there's definitely something wrong with my volume pot. I think I've mentioned this before about these crap potentiometers. So this is the one that was on it. So there's my meter reading across the wiper and one end of the pot. 65k. It's behaving a little bit more now since I sort of tightened the central wiper. See what I mean? It's sort of dancing all over the frigging place. See? So, don't buy the damn things. Where is it? Right, made in the UK. Made in the UK. Citec, C-I-T-E-C. Sorry lads, but the shite. So best avoid. Buy, you know, pay a bit extra, buy bond spots. Right, let's bang this, let's test this amplifier. I'm hoping you can see the scope and then the meter. I'm going to crank the volume up a bit, change the scale. Right, that's better. That's a hell of a lot better. Ouch. 4 volts RMS. Right, 0.04% THD. That's pretty good. So, I mean, what a difference a different potentiometer makes. So, you know, that's one that can catch you out. You think your amplifier is playing up. It's your pot. 18 volts. It's supposed to do about 75 watts. Okay, we're clipping there. 21. I know that's below. Let me see. Come on, think. 19.0 special. Okay, we've got 60 watts. Let's just knock that down a bit, see what the distortion is. Right, that's not bad, is it? 0.02 at 14 volts RMS. Just chibble that down a bit. 6 volts. Right. Frequency 100 hertz. Right, what were it before? Right, let's do it properly. Frequency 1 kilohertz. That one. That's a 0 volts. Frequency 100 hertz. Right, minus 0.02 dB down at 100. Okay, minus 0.3 dB at 20 hertz. Not too bad, is it? It's supposed to be good up to about 60 kilohertz. Frequency 30 kilohertz. Right, there we go. 1 kilohertz, 1 dB. Frequency 50 kilohertz. Okay, so we're 1 dB down, 1.1, 1.2 dB down at 50 kilohertz. So not too bad. Frequency 30 kilohertz. I'm not going to bung a square wave in there because it's not biased properly, and yeah, so let's talk about that. So a lot of what is letting this amp down is probably because I haven't built it correctly and the layout is abysmal. As you can see, I replaced that 2U2 axial electrolytic with a film cap. Probably didn't need to. I think it was just the pop there. So I was just doodling on a bit of paper earlier on, just trying to figure out the layout, and I know I can get the layout a lot smaller. These massive heat sinks, I bought about 10 of them for £1 like ages ago, and I've never really found anything, you know, where I could use them, because they're either too big, well yeah, they're just too big. Anyway, I have a couple of, two more output devices. I'm either just going to leave it alone or build a stereo version and, I don't know, try and think of a use for it. I mean, it's not as if I've got, it's not as if I haven't got enough amplifiers. I've got too many of the damn things, but hey, you know, this is what it's all about, isn't it? Building amplifiers, testing them, and then forgetting all about them, or listening to them. No point putting any music through this one, I don't think, really. Hopefully in the future I'll get time to build it properly, build a stereo version properly, and sort out some of the issues with this. One of the issues was that 2 red LEDs that I got here, that's about 3.5 volts, meaning that the constant current sinks sources aren't set up properly. Also, over here we've got our 2 transistors for the differential input. Strictly speaking, if we want to get like really good performance, they need to be mated thermally and matched. That would make it just a little bit better, and obviously sort the layout and things. So I don't know, if I get time I shall try and do that. May as well. Hey, anyway, thank you all for sticking around and watching this. So we failed on the guitar amplifier. I don't know, I could try and sort it out, but I'm never going to use it, so I'm just wasting time. This turned out okay. I'm just going to turn that off, and then I didn't have time really. I didn't have time to look at this tele-equipment S51A. These scopes back in the day were used a lot in schools and universities. So yeah, I tried to get this going about 10 years ago. Didn't quite succeed. I've got a sneaking suspicion that the cathode ray tube is knackered, because I could get a trace but it was very dim. This is worth getting going because it has a blue phosphor, which is quite snazzy. So yeah, so I'll see if I can get that going sometime. And then there's a few other little bits and bobs as well. Thank you all very much for watching. Take care of yourselves. Ta-ra for now.